Hello everyone, welcome to Ladboy Coding. Today we're going to solve problem 1026, max difference between node and ancestor. And we can see this is a really commonly asked questions by Facebook. So let's see the problem. Given a tree, we need to find the max value for which there exists a difference between node A and B, and node A has to be an ancestor of B. So first of all, what is an ancestor? So for example, node 3 has ancestor 8, and node 1 has ancestor 3 and 8. So ancestor is all the node above it. So yes, this is the problem. And given this tree, the answer should be 7, because in this tree, the maximum difference is 8 minus 1, which is 7. So yes. So this is our tree, and we need to find number 7. So we need to traverse every node, and we also need to know the ancestor. So we need to traverse all the nodes, and we also need to keep track of the ancestors of a single node, right? So for example, starting from here, we know it has no ancestors, and we initialize the maximum difference as largest number. Then we go to 3 and 10. First, we go to 3, and we know 3 has an ancestor 8. And then we check the difference between 3 and 5. It is 5. So we update the difference. 5. Then we go to 1. We know 1 has 2 ancestors, 3 and 8. So we check the difference between 3 to 1 and 8 to 1. And the maximum difference is 7. Then we go to 6. 6 also has 2 ancestors, 3, 6, 8. Then we check the difference between 3 to 6, 6 to 6, and 8 to 6. The largest difference is not larger than 7. So we go to 4. The ancestor is 6, 3, 8. Then we check the difference between 4 and 6, 4 and 3, 4 and 8. The maximum difference is 4, not bigger than 7. We go to 17. We go to 77. We go to 77. The ancestor is 6, 3, 8. The maximum difference between ancestors and the nodes is all negative number. It is not larger than 7. Then we go to the right side. The ancestor is 8. The difference is -2. It's not larger than 7. Then we go to 14. The ancestor is 8 and 10. All differences are negative. We go to 13. The ancestors are 14, 10, and 8. Now we traverse all the nodes and we find the difference 7. So how should we do this? How should we traverse all the nodes? We use a stack to do a depth first search. Okay, now let's code it. So if there's no root, we just return 0. Otherwise, we initialize the maximum difference as the largest number. First, we initialize the maximum difference as the smallest number. Then we initialize the stack and we put the root on the stack. That's how we do the depth first search. So when the stack is not empty, what do we need to do? So we need to put its ancestors and the current root to the stack. So ancestors and node, we get it from the stack. We know the current value is node.value, and for number in its ancestors, we need to update the maximum difference value. So it should be the current value comparing to the ancestor number minus the current value. Then if the node has a left child, we need to put the current node as an ancestor of the next node. So ancestors plus the current node value, which is current var, and the next node. Same for the right node. Then in the end, we just need to return the max diff. So let's run it first. So let's run it first. Yes, it's correct. And let's see our ancestors and node.value. Oops, typo. Okay, so let's visualize the stack. So on the root level, it has no ancestors. And then next node has ancestor 8. Next node has ancestor 8 and 10. Then the last node has ancestor 8, 10, and 14. Same for the right side. Yes, that's how we do this problem. Now let's run it. Okay, we need to get the absolute difference. Yes, that's it. So let's analyze our time-space complexity. The time complexity is O of n squared. The space complexity is O of n because we use a stack. Why n squared? Because for this node, we need to traverse all its ancestors. And for this node, we also need to traverse all its ancestors. And there are n nodes. For every node, at most, we need to traverse all its ancestors. So that is n squared. Okay, thanks for watching. The key point is to know how to use depth-first search. If my solution helped you, please feel free to leave a comment. See you next time. Bye-bye.